Alright, Algebra 1, in this video we are going to talk about relations. We are starting a new unit. This is the beginning of the new unit. This is the first lesson, so make sure you are taking notes, writing down any questions you may have. As usual, when you watch a video, my advice is to try any of the problems on your own first and then hit play to see if your answers match what I have. Now, granted, this is a first time through of this, so you might not have seen this before, but it doesn't mean that you can't pause and try the parts that are asked of you. So definitely after, you give you the notes, I give you a problem to try on your own. So see what you can do with those and then just press play, see if you got it right. If you did, awesome. If you didn't, that's okay. Just write down the correct work so that you can learn from it. So first things first, in order to talk about relations, we need to define what a relation is. So what is a relation? It's a connection between two sets of data. Typically, you want to relate a set of inputs to a set of outputs. So you can relate anything, like think about in your life, you have relations, like relationships with people, you have connections with people, you have connections with places, you have connections with stuff, like objects, like your phone. And then technology makes us have relations with who knows what, like think about how many connections you might have made through TikTok or Instagram or Snapchat, things like that. In math, there are connections too, and we'll talk specifically about a type of relation that's really important for us in math classes, but in this lesson, we're just talking about relations in general. So a relation, like I said, is that connection between a set of inputs and outputs. Inputs are typically things that we choose. So for example, let's think. I always try to think of something relevant, but I live under a rock, so I don't always know what's relevant. But like my input might be, I want to watch TV shows, so I go to Netflix, and then the output is whatever Netflix has for me, right? So there's tons of connections between inputs and outputs. The inputs I choose, right? I chose to go to Netflix, but then the outputs were there for me. That's what Netflix has put out there. The input is normally something we choose. And the outputs are the result of that input. And I suggest that you take some time, maybe pause and think about types of connections that make sense to you. Like I've just rattled off a few, but maybe you don't relate to those. Like I don't really relate to anything that has to do with TikTok because I don't use TikTok. But for me, Netflix is a big one. When I do have some downtime, that's what I go to. So think of something that you have a connection with, that what will the input be and what is the output based on that input, just to try to think of how this relates to your own life. So we can represent relations in 5 different ways. Some of them you are already familiar with. This first one we're going to talk about is probably the newest one to you, so that's why I want to talk about it first. So the first one is called a mapping diagram. And mapping diagrams use arrows from the input to the output to show which elements are related. So if you're doing this in Google Docs, you can just double click this image and it'll pop up as a drawing, and you can use the text box to input the information into here. But so in an example, if I give you that my inputs are A, B, and C, and I tell you that the output options are D and E, you can sort of think of this almost like a vending machine. If you put A, the code A in, you'll get something out, right? In this case, I'm going to show what you're going to get out. So if I put in A, I expect to get out E, whatever E is. If I put in B, I expect to get out D. And if I put in C, I also expect to get out E as well. Right, so that's showing my relation between the input and its specific output. The same way that I clicked Netflix and then it picked a bunch of shows that are only on Netflix, right? If I picked Hulu, I would get a bunch of different shows. So things to remember about mapping diagrams. The lines need arrows on the end of them. So just on one side, pointing from the input to the output. So make sure you write that down. Right, because we really want to signify which direction we're going. And then the other rule is we don't write repeats. Notice how E was used twice here, but it's only written one time. So I don't write it twice. So we don't write repeats in the input or output. You should also put titles on your circle. These are already titled, very basic input, output, but if there were something more specific like network and TV shows, right? Like, again, I don't really watch live TV. Like, okay, ABC or Channel 7 would be my input. My output might be Grey's Anatomy, so I could put the titles as network and TV show that go hand in hand. So we don't write repeats, and then, like I said, lastly, titles on each circle. They don't have to be circles. They can be ovals, they can be squares, rectangles, whatever. So I'll just put on each set. So don't necessarily think like, oh, it's a square, it's not a mapping diagram. No, it's okay. It doesn't matter what shape the mapping diagram is. So that's mapping diagram. The next thing I'm going to talk about is tables. Tables we should be familiar with. We've been working with them this year. We used them in Unit 1 when we talked about arithmetic and geometric sequences. So I'm going to pick some inputs. Remember, relations can be between anything. You can have food, you can have people, you can have letters, numbers, anything. So normally in this example, I use letters to relate it to what we just did in part A, but maybe this time I'll use, I don't know, let's use like a color and a number. I don't know. I'm making things up here, right? So if my input is red, my output is going to be 7. If my input is blue, my output is going to be 9. If my input is pink, my output's going to be, I don't know, -3. And if my input is green, that will also output 7. So I've created my table. I want you to use what you know now about mapping diagrams from above and try to take your information from your table and turn it into a mapping diagram. Again, if you're in Google Docs, the mapping diagram is a drawing, so double click it and then you can edit it however you need to. But I encourage you to pause the video right here and start working through making this table into a mapping diagram. So there are already titles for you, but if I wanted to be specific, I would call this color and number. And I'm going to put my colors in. So red, blue, pink, green. And I'm also going to put my numbers in. 7, 9, and -3. Notice, even though 7 showed up twice in the output, I did not write my repeat here. That's the whole point of the arrows, right? So I'm going to then match, right? Red went with 7. Blue went with 9. pink with -3, and then green also goes up to 7. So the arrows are showing the matching, right? Mapping diagram is just like matching. So again, I'll write it out. Notice how 7 is only written once in the output. So the whole idea about relations is I can represent them in so many different ways. So right now we've just talked about tables and mapping diagrams, and we've shown how we can share the same information with somebody using 2 different representations. We can also talk about ordered pairs. Ordered pairs should not be new to you as well. They're just points in the form of input, comma, output. Most commonly, you'll see them as x comma y, and we'll talk about that in a second. But here, again, I can use anything when I talk about relations, right? They're connections. So for the example here, I used teachers and subjects, right? Mr. Zaki, myself, my relation to a subject is math. Miss Moses' relation to a subject is English. Mr. Sinar, social studies. Mr. Scally, special education, right? And I could have a couple of different relations, but math is my main relationship to a subject, right? So my main connection. So that is showing ordered pairs with teachers and subjects. Take that information and turn it into a table. So again, I want to put titles on my columns. So here I'm going to put teacher. Here I'm going to put the subject that the teacher teaches. And then I'm just going to write in the information. And I'm going to abbreviate because I'm not going to fit special education on that box. So I can go also from tables to ordered pairs, right? The whole point here is to understand that you can go from any form of representation to another. We can also have graphs. Graphs represent relations. So inputs are your x values typically, and outputs are your y's. We've seen graphs when we talked about, again, arithmetic and geometric sequences back in the beginning of the year. I know that seems like forever ago. It was only 2 units ago, but seems like forever ago. So it says, can you take the information from the graph, right? So the information from the graph are these ordered pairs, these points, right? And can you turn them into ordered pairs? So can you write them out as x comma y? So pause the video, take a second to do that, see if they match up. Be careful here. If you notice, I skipped lines. So each of these is actually 0.5. And each of these, this is going by 2's. So be careful there when you create your ordered pairs. So when I start here, I'm going to look at this point here. To get to this point, if I started at 0, 0, I had to go over to the 1, and then I had to go up to the 4. So this is 1 comma 4. That would be x comma y, 1 comma 4. Right, then if I move, it doesn't matter what order you go to these. I'm going to move here next. If I follow this over, the x is 2.5 and the y is 8. So this one is 2.5 comma 8. How about this one up here? If I go over, it's at the x value of 2, or the input of 2. What's the y value there? it is 14. So this is the point 2 comma 14. And you don't have to put these lines in. I'm just showing you how I've gotten my answer. Continuing on, there's 3 more points here. Don't miss any of them. This one is 3, 8. We then have this one down here. This one is 4, 2. Careful, it's not 4, 1. Remember, watch that scaling. And then the last one, which is way up here, this is 5, 20. So I've taken all of the points in the information from the graph and I've turned them into ordered pairs. What if my points weren't scattered? What if my graph was a line, right? Technically on a line, there are an infinite amount of points, right? There are easy ones to identify, like the ones that are in what I like to call the corners. So where the lines kind of meet, those are the easy points. But they're not the only points on the line, and we've talked about this back at the beginning of the year. So these are the main points of the line. They're the easiest ones to identify, and I can write ordered pairs from those fairly easy. There are an infinite number of points, though. I can kind of come up with an ordered pair anywhere on this line, right? Any of these green dots would work. The only reason we don't really use them is because I don't know what the numbers are exactly. They'd be estimates. So we don't typically look at those. So we focus on, like I said, those big orange ones because those big orange ones are directly at a corner. It's easy to identify what the numbers would be. So take a second, and it says write at least 2 ordered pairs. So at least means 2 or more from this graph. Okay, so take a second and do that. For me, again, I think it's easier if there are no like physical like points, like circles on the graph. You might want to add them in. So we add them anywhere the graph or the line touches a corner. And a graph doesn't just have to be a line. We can have curves, and we can do some examples of those in class. But for now, we'll just talk about a line. So these are all the possible ordered pairs that you can really pick. Now, like I said before, there are an infinite amount of ordered pairs that you can choose from, but these are the most direct that will give you exact values, integer values, integers are whole numbers. So if I look at this topmost point, this is 2, 8. Then I go over nothing and up to 4, so 0, 4. Then I go left 2, right to the 2, that's -2, but I went up nothing, so -2, 0. Then -4, -4. And last but not least, down here, -6, -8. So any 2 of these, if you wrote, good for you, they are all possible. Like I said, I could estimate like this point here. I know the y value here is -6. But I'm sorry, +6, but I don't know the x value. Maybe it's 1, maybe it's 1.5, maybe it's like 1.125, like I don't know, so it's not really a great ordered pair to use. That's why we use the ones that are marked in orange. The last representation of functions that we're going to talk about of relations that we're going to talk about are equations. And we should be fairly comfortable with equations because we've been working with them all year long. We just solved equations, right? We solved for x and things like that. Typically, we're going to have equations with 2 variables, so y and x. So here they're saying which variable represents the input, that's always the x, which one represents the output, that's the y, right? So this is talking about some sort of relationship between x and y values. And the relationship is that in this case, right, so here this says the relation or the connection is that we take the x values multiply them by 3, because that's the 3x, and then add 2. So that's the relationship between x and y, right? Y is x multiplied by 3 and then increased by 2. So given the input, sometimes they're going to give you an input value and ask you to find the output value, and this is something that we've done before. So given the input, how do you find the output? We just use substitution, right? So we're going to substitute the output, or sorry, the input, that's the one we know, the input value for x, and evaluate using PEMDAS to get y. So there are 2 examples here. Again, I encourage you pause the video right now and try it. It says using the equation from above, so that's the y equals 3x plus 2. Find the output, so find the y, right? Find the output, that's y equals, we don't know. If the input is 2, so that means we're looking at x equals 2. So take a second, pause the video, give that a try, and let me know what you get. Well, I guess you can't let me know what you get, but see if you got the same answer that I get. So I'm going to start off with my equation. I'm going to write that down. And I know that x is 2, so when I substitute, I need to use parentheses. So I like to open up blank parentheses and then put in the necessary information, which in this case is 2. And then I'm going to simplify. PEMDAS says to multiply first, so I'm going to do 3 times 2, 6. Add 2. So that is 8. I can turn that into an ordered pair. I know the input was 2 and the output was 8, so my ordered pair would be 2, 8. I could take that and I could put it on a graph, or I can put it in a table, or I can put it in a mapping diagram, right? But this would be the ordered pair that came from this input and output. So then same type of question here. We're using this same equation. It says find the output, so find the y. If the input is 10, so remember the input is the x, so I know the x value, so I'm going to use substitution again. So I'm going to have y equals 3x plus 2 is my equation. I'm going to replace the x, or substitute the x, with 10, and then follow PEMDAS. Again, multiply first because of PEMDAS. So here I'm going to multiply, that's 30. I'm going to add 2. So y equals 32. So y equals 32 because of the input 10. So the ordered pair here would be 10, 32. Didn't ask you for that, but I figured it would be nice to show you how even from equations I can create ordered pairs, graphs, tables, and more. One more little part here. So we just found the output given the input. Now I want you to find the input given the output. So sort of going the opposite direction, right? So here we're going to substitute. It's all about substitution. It's just making sure you substitute for the proper variable. So you're going to substitute the output, which is the y, and solve for x. Right, and solve means like get x by itself, isolate it, using what we just learned in our last unit. So again, pause the video, give it a shot. You're using that same equation, that same y equals 3x plus 2. And here it says find the input, so this time we don't know what x is. if the output is 17, and I don't want you guessing and checking here, I want you actually doing the math out, like using the equation. So I know y is 17, so I'm going to substitute. Right, substitute means replace. So 17 equals 3x plus 2, and now I just need to solve for x. So I'm going to subtract 2 from both sides and divide by 3. Right, so I get 5 equals x, or x equals 5. Order doesn't really matter here. And then if I wanted to turn that into an ordered pair, it would be 5, 17, which I then could put on a graph or a table or mapping diagram or anything like that. I can compile all the ordered pairs together and make a graph out of it, but I'm not going to do that. And last but not least, last example here, again, find the input, so find x. If the output is 11, so they're telling us the y value is 11 here. Using this same equation from above, I'm going to have 11 equals 3x plus 2. I just replaced the y. And then I'm going to solve for x again. So minus 2 from both sides, 9. Divide by 3. So 3 is x, or x is 3. And the ordered pair here would be 3, 11, because that's the matching input and output. So that's relations in a nutshell. Again, I can represent them 5 different ways: mapping diagrams, tables, ordered pairs, graphs, and equations, and I can transform from any of those representations given one or multiple. If you have questions, let me know or write them down, and I'll be happy to answer them in class. Thanks, everyone.